Hey everyone, welcome to this week's latest in Bitcoin session. Today we'll look at one news item which is related to the feature called as AssumeUTXO. We'll look at what AssumeUTXO is, how does it work, and what are all the problems associated with the current mechanism that AssumeUTXO uses, and about this draft BIP, which proposes a solution to this to improve AssumeUTXO's uh, operational efficacies. So, so AssumeUTXO is a solution that has been put forth or invented in order to address the issues associated with initial block download when you set up a node. So as most of you know, when you set up a node, the node starts with a process called as initial block download. That's when the node talks to its peers, collects information about blocks right from the Genesis block, and then starts verifying each and every block, its constituents, that is the transactions within the block, the scripts that are inside each and every transaction is all completely verified, and the signatures are also verified. So this process is time consuming given the size of the blockchain right now. Um, so typically on a system with a decent processing capability and storage capabilities, fast storage capabilities like an SSD. Right now, it will take around 2 days or so is what my guess is. I'm not very. I didn't look up the current numbers, performance numbers. Uh, the the time becomes worse, or it becomes longer if your storage medium is not very fast or nimble. Uh, if it's a hard disk, like a spinning hard disk, then it will likely take more than a week. At least in my case, when I uh, try to set up a node on a uh, PC, mini PC with a uh, rotating hard disk, it took me close to 10 to 15 days, I think. That's what I remember, to get the IBD completed. So this the so one problem is, okay, fine, IBD can take its own time, but however, the problem is that the node it won't be active, or you won't be able to use the node until this IBD is complete. Only if you reach the tip of the chain, only then can you start using the node for its own for its complete functionalities, like broadcasting your transaction, syncing, or verifying the transactions that you received, etc. So this IBD, the slowness of the IBD is has been an elephant in the white room when it comes to ease of access or seamless setting up of nodes in Bitcoin. So, so in order to solve this problem, this idea of AssumeUTXO has been introduced. So AssumeUTXO is based upon the snapshot technique that has been used with assume valid uh, idea. So we'll also look at what assume valid is, and you might have also heard about assume valid. There is something called as there is a feature called as assume valid. So we'll also look at it, how it is different from assume UTXO. So assume UTXO, what assume UTXO does is that it provides the node with a snapshot of the UTXO set itself till a particular block. Let's say let's say till block number 840. So till 8 all the UTXO that is available, uh, that is valid till block number 840 is provided as a package uh, to the node, and the node assumes that the UTXO set provided is the truth till 8 block number 840 thousand, and then starts constructing blocks and deriving UTXOs out of those blocks after block number 840. So this significantly speeds up the IBD process or syncing process, and gets the node into a usable condition where relatively quickly. So this is how a default node syncs. So it starts from the Genesis block, it validates block one, it gets a UTXO set out of this, then it goes on to validate block two. Some of the UTXOs that were present in block one might have been consumed in block two, so the UTXO set changes in block two, and the process goes on until it reaches the current block tip. So whatever UTXO set that you have at the current block tip is assumed to be final. So this is the default sync process, and this will take its own time, as we saw here, because it has to do all this process: signature verification, script execution, database update, IO writing, etc., for the whole chain. However, when we move to Assume UTXO, so the UTXO snapshot at a block n, let's say 840,000, is already provided to the node. Um, so the node assumes that till block number 840,000, everything is right, and it also has a set of UTXOs with it that corresponds to the state of the chain at block number 840,000. Then it starts to build blocks on top of it. That is, by collecting information from its peers, it starts to build or validate blocks from n onwards, n plus 1, n plus 2, and it goes on till the current tip. And the UTXO set which it got here keeps changing as it catches up to the tip. So this process is much more faster than the normal IBD. So normal IBD is a time consuming and involved process. But this UTXO set is pre-built and provided to the node when you use AssumeUTXO, and the, the the tip of the chain is will be catched up soon by relatively sooner by the by the node when it uses AssumeUTXO. So I'll pause for a second. If there are any questions with respect to this process or how AssumeUTXO, the idea behind AssumeUTXO, if you have any questions, please. Yeah, right now, since core Bitcoin Core version V28, this number has been fixed at 840,000. It has not been, I think it has not been changed till now. I think after a few versions down the line, this number might be revised a little upwards. So right now it's hard coded. Okay, so we'll have a look at this Assume UTXO workflow itself as a. So this is the what we saw here is the concept, and now we look at how it is actually implemented. Um, so it is via a combination of hard coded uh, block numbers, and also hard coded and also a set of RPC commands. That's how right now it is implemented. So so the first step is that if you want to use Assume UTXO, you need a snapshot file. So it is typically a dat file, which is nothing but a serialized UTXO set in compressed form. So you need to get this file somehow. Either you have to have another fully synced node from which you can get, or you'll have to get it from trusted third parties. That is how it is right now. That is a problem itself. So we'll see how the BIP proposes to address that. So the current state is that you need to obtain this snapshot file, and you can load this snapshot file using this RPC command called as load tx outset. So if you use this command you have to load this in Bitcoin Core versions from V28.0 onwards. So AssumeUTXO is available only since this form of fully fleshed out AssumeUTXO is available only from version 28. So first thing is that you load this snapshot file. Then the core checks whether the snapshot, whether the checks the snapshot against the compiled AssumeUTXO data. So what happens here is that um, in the core version itself there is a hash that is hard coded that encompasses all the information that is actually in the utxo.dat file. So what core will do when it loads this file is that it will hash the utxo set's contents. So the UTXO set will have its out point and value and other informations. So all these things are serialized and then it is hashed. This hash, which the core gets from UTXO dot file, is checked against a hash that is hard coded into core itself to make sure that whatever file you are uploading is the right file and not some arbitrary data. So once this check is done, then it will go on to create a second chain state. So you can imagine it as as the software itself maintaining two different chain state folders in your drive. One will be the default chain state where verification goes on starting from the genesis block, and this parallel or secondary chain state uh, will be the one that will be used by assuming that the UTXO set that you have given till block number 840,000 is correct. So it will create a parallel chain state or a second chain state, and this snapshot chain state or second chain state becomes the active chain state, and the software starts building on top of this chain state. So if it is block number 840,000, then it will start building from block number 840,001. So the blocks gets built, the UTXO set gets changed, um, and the snapshot chain state will reach the tip, while in the background so once it reaches the tip, now the node becomes usable. You can verify your transactions, you can broadcast transactions, and all those things can happen with your node because it becomes usable. So however, in the background, the original chain state will be continues to be uh, continues the validation process. So maybe it is in block number 700,000 or something, and it keeps validating and continues to create the chain as though this snapshot doesn't exist. So once it keeps continuing and it reaches this block number 840,000, what it will do is that it will do the same process of hashing the UTXO set and comparing it with the hard coded hash in the software. So what this will tell is that whatever the the node has built by engaging in peer-to-peer message exchange uh, is also the same as the hard-coded value. So now this confirms that the chain that has been built in the right way, and also the chain that has the snapshot, both are the same. So once this validity is confirmed, what the node will do is that uh, it will uh, it will discard um, discard this um chain state that it constructed from the genesis, and it will start using only this snapshot chain state, as the snapshot chain state is the one that is at the current tip. So in all that the node wanted to ensure is that construct blocks from genesis till 840,000, make sure that till 840,000 both are same. If that is the case, then it is good enough, and you can continue using this snapshot change state, and that becomes the only change state that the node maintains. So so this is how the AssumeUTXO workflow works. So if you have any questions in this workflow, I'll pause for a moment. Then we'll look at some of the problems associated with this workflow and how to address it.
Hi,
Yeah.
is there any way in which a person who is running node can decide whether he wants to keep the original chain or he want to keep this assumed wala jo chain hai? Means he can decide
Uh,
between those two. And
no,
is there any way?
no, no, you can't decide because the the original chain state that your node constructs from Genesis will be constructed only till 840,000. So once your the node that you construct from Genesis reaches 840,000, it will check whether till 840,000 the chain that you constructed yourself and the chain that came from the that you assumed are both the same. So if it is the same, then the chain that you constructed till 840 will be discarded, and the snapshot chain or the chain that came to you will be considered as the true chain, and the blocks will be built on top of that.
And I just also wanted to ask you, if all the nodes are rejecting that original chain, then from where does a new node gets that data for building up that original chain till the block height of 840,000? Since all the nodes
Uh,
are rejecting, so how it is getting that data?
no, and no nodes will reject this data. The uh, only shortcut that you are taking here is that you are not waiting till your original chain is constructed till the chain tip till let's say now it is 980,000 is the block height. So you don't want to wait till your chain gets constructed till 940,000. You want the UTXO set, you want the correct UTXO set, and you want to use it from, like, let's say from half an hour in setting up your own node. If that is the case, then the shortcut that you are taking is that let the chain keep building on its own in its own speed. I will not wait for the chain to build. I will take the shortcut, or I will compromise on the assumption that till 840,000, which is hard coded in the core version, I will take the shortcut, or I will compromise or make an assumption that till that it is true, and I will start constructing blocks on top of 840,000, and I will start using the UTXO set as quickly as possible. Uh, the data, where will the node get the data is that there will be other fully synced full nodes everywhere. So those nodes will have the data from Genesis till the most recent uh, block. So that data will be served to all the nodes around it.
For example, if I take my node will be having these both chains. It will be having
Yeah,
that
yeah,
assumed UTXO set and even that build-up chain from the Genesis,
yeah,
but it is
yeah,
using
yeah,
that 840. Okay, okay,
yeah, yeah. But I also got your question. I think I
So
I,
Bala, so
I also didn't think about it. Whether both the chains will be merged or the one that you built from Genesis will be discarded. That point I'm also not clear. I'll also have to look into the
Bala, is it
look into the
considered a full node if you're using Assume UTXO or till it catches up?
code. Till it catches up, you won't be able to serve the most like let's say the node Genesis you are building from Genesis node and it is somewhere in block number 100,000 and the
Mhm.
current tip is at somewhere around 900,000 and you
Yes.
are at the tip on your AssumeUTXO chain, but
Mhm.
the actual chain that you're building is at 100,000. You will be able to serve to your peers only information till 100,000.
But
The
why? So
balance,
technically, no, no. What I'm saying is it considered a full node? So for a full node validates, right? Technically, for
yeah,
me,
yeah.
because it is going on valid data, it should not validate transactions. So I don't get the point of why they should be considered to validate the transactions if the data they're using is
No,
assumed.
it still does because the validation is not completely cut off. It's not something like a prune node where uh, you don't even go into validation at all. The validation happens, but in a parallel chain in the background.
No, I get it, but I think so. It is worse than the prune node because in the prune node, at least I've downloaded everything and then I'm discarded. This though I'm starting with the assumed UTXOs.
Yeah, that is a compromise that you are getting into in order to speed up the IBD or start using the node right after you install
I get it.
the.
I got that point, but the point is that your node technically should not be considered valid. You should not be able to exchange information with other full nodes. That was my point.
No, no, it can because that's what I'm telling now, right? Anyway, your node will start complete verification from Genesis block when you start the node. So that process keeps going on in the background. When that process keeps going on in the background, it will interact with peers and it will share information with peers
I
about
no,
blocks
I
that it
that,
has completely
that I
confirmed,
get.
even if it is
No,
the
no,
block
yeah,
number two.
yeah, yeah. So my understanding is it will start with the assume UTXO, and then it will start adding 841, then 842, 841, 813, right?
Yeah,
But
yeah,
in the background, it will start with 1, 2, 3, 4 till it catches
yeah,
up to 8,440, right? But
yeah,
what I'm
correct.
saying is that the after the 8,000, the assume start from it. So the 8,000, 800,000, 40,000, and 1. That one
Yeah,
which is adding to, how can it be sure that? So again, it should not. So it is sharing data with the other nodes, right? That I think should not be
yeah.
allowed
That
because
no,
it,
no. That I'm not sure whether the parallel chain snapshot chain is shared with peers or not. I'm not sure, but it's a valid question. I'll have to check and then get back.
okay, got it.
Yeah, but this the original chain that I know for sure that that information will be shared with the peers, but I'm not sure whether the snapshot chain itself will be shared with the peer. Yeah, nice question.
Got it.
Thank you, Amol and Rajendra. I'll check that and then maybe put a message in the chat. So the problem with this process is that uh, there are very dangerous assumptions involved here. The user has to obtain the UTXO snapshot file from somewhere. So that's a big assumption and big ask. It doesn't. It's not the right way to do stuff. So now either he has to has his own parallel node in order to get that file from his own node. So that is a is a unworkable assumption. The other option is to download it from somewhere. So that is a big risk, potential risk in terms of privacy, malware, etc. So this doesn't scale. This doesn't work. So you need something else. So the other solution is that the snapshot itself should be distributed via the P2P connection that your node makes when it is fired up with its PS. So it has apart from giving you information about the block and all those things, your peer should also give you information about the snapshot. So this is the cleanest way in order to bootstrap the snapshot without relying on any third parties. So in order to do that, this is a draft BIP is all about. So in order to do that, the draft BIP proposes to introduce one more service bit in the P2P message exchange, not in transactions or anything else, but in the P2P message exchange protocol. The draft BIP wants to introduce a service bit called as node UTXO set. So when this bit is set, that means my node knows about this protocol called AssumeUTXO, and it is ready to share information about snapshots. So that's what this service bit will convey to the PS. So once I find a node that can serve me snapshots, then I'll ask it to give me the snapshot via a service message called as get UTXO tree. So these are all P2P message exchanges, not RPC commands. It'll ask get UTXO tree. The peer will serve me the snapshot in chunks, and these chunks will be constructed into a Merkle tree. And eventually, after receiving all the chunks or all the branches of a Merkle tree, I will finally assemble the Merkle tree and then construct the root hash. So this is the basic idea. So you'll get the UTXO tree, via get UTXO tree, you'll get all the chunks. Then the UTXO tree, it is so 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 these chunks are uh, typically in bytes of 3 MB, and this chunk data is hashed 256D double hashed, and then constructed into Merkle roots. And once you receive all the chunks, you will arrange them and construct the root. Here, how the question is, how do you know whether the chunks that you received are all correct? You have assembled them in the right order. How do you verify that? Only if only if you are sure that you have assembled the chunks in the right order. You deserialize them and extract information about uh, UTXOs from that whole chunk. So how do you make sure that you have the right chunk and you have constructed the right order? That is by what the BIP proposes is you do it by verifying the root Merkle root that you construct with a hard coded or um, uh, uh, right now the best idea is to hard code the Merkle root hash itself. So instead of earlier, right now what we are hard coding is information about the height 840,000. So instead of hard coding this, the new BIP proposes to hard code the Merkle root of the chunk. And once you construct the chunk, you will verify whether the chunk that you constructed is equal to the hash of the Merkle root that was hard coded. So now you can be sure that you received the right information, you have successfully constructed the right information in the right order, and now you can go ahead and deserialize the whole chunk and then start extracting information about UTXO, and you can reconstruct your UTXO database itself. So this is what the proposal is. Even this proposal has one assumption, which is with respect to the hash of the Merkle root itself. There are right now only a few methods in order to distribute this hash. One is the obvious one of hard coding it. Then the second one is relying again on external trusted sources, and the third one is that you have multiple peers that agree or serve this information, like the DNS seeds, like how the DNS seeds are served to you in your node. So this is how the new proposal is in order to modify AssumeUTXO. So, any questions
Yeah,
around
Bala,
this?
why are they making it so complicated? So why don't they just use the block header, make a Merkle root, go to the Merkle tree, go to the root, and share that root hash with everyone, whatever block they want. So they can add it to the what do you call it, the difficulty adjustment. So every 2 weeks there will be a new
No, no,
snapshot.
no. This is not related to the block itself. So this is related to the UTXO set. So
This is no,
what
I get it,
inform?
but assume UTXO is just that so that you can start using your node from the instantly, right? That is the purpose of this of it, right?
Yeah, yeah.
That
No,
I will get the
that that also means you need the right UTXO set. So you just only if you have the entire blockchain alone, that is not enough. So you need to construct the UTXO set or UTXO database also from the blocks. So uh, what this Assume UTXO is all about is helping you get the latest UTXO set in a in a in an accelerated timeline.
I thought it was just that so you can start using your node right away. And the UTXO that set so the UTXO set is a slower is a lower bandwidth, right? Basically, the size of it is much
Yeah,
lower than the blocks themselves, right?
yeah.
So
It's not for
yeah, so what I'm
it's not
saying is
tough.
yeah, so if you want to just use your node, you can just make a Merkle tree with the block headers, go to the root, hash it, and that hash can be shared. And once you get so that can be the assumed block starting point, and then you can start adding to it. And then in the background, you can start with the one number block Genesis block and go up to whatever block is, and then you can verify on the back end if the your assumed one block header is hashed block header root is valid for the blocks you have already or you have started downloading and cached up. So that you can match, and then you can. So that I feel is much better than actually doing this complex
Yeah,
procedure.
that's what assume valid is all about. So assume valid is nothing but you assume that the information that you have, or you assume that till X number of block, you assume that all the blocks are valid, and you start working on blocks above that. So that is about assume valid, which is related to uh, the block itself. Okay. But that assume valid has nothing to do with the UTXO set. So even if you assume that till X block everything is valid, you are not going to verify it. But still, you have to address this problem of how do you build the UTXO set. So for that, you again have to go and verify the transactions from Genesis block one, and construct the UTXO, mutate the UTXO for every single block. So that process you have to do. You can't skip your constructing of UTXO set. So in order to address this problem of constructing the UTXO set in a much quicker fashion is what Assume UTXO is all about.
Got it.
Yeah. So assume valid, what we have to remember in a very crude or rough sense is that assume valid takes care of speeding up the IBD with respect to just the blocks. However, you need the UTXO set in order to start transacting with your node in order to make sure that you construct in order to keep your wallet up to date, in order to have in order to make sure the UTXOs in your UTXOs show up on your wallet. You need that UTXO set on your node. So you need to construct that as quickly as possible. So in order to solve this problem, we are trying to create or trying to standardize this AssumeUTXO feature. So yeah, so that's all I have for today. I hope everyone was able to understand what is the difference between Assume Valid and Assume UTXO and how Assume UTXO works.